I'm now going to be talking about some anaerobic adaptations on the cardiovascular and respiratory system, the neuromuscular system, the energy systems, and the skeletal system. So first off, the cardiovascular system and respiratory system. Training such as plyometrics has many benefits to the cardiovascular system and the respiratory system. A benefit to the cardiovascular system includes myocardium hypertrophy, which I've talked about earlier in this presentation, and it's when the heart walls become stronger, meaning that the heart doesn't need to work as hard to pump blood around the body. Some other cardiovascular adaptations include stroke volume increases and heart rate decreases. Heart rate decreases as more blood is being pumped out in one beat, so the heart isn't having to work as hard, and so the heart rate decreases. The stroke volume is affected, as if the heart wall is stronger and thicker. It means that the heart can pump out more blood in one contraction, and so the stroke volume increases. The respiratory system doesn't really experience many benefits, as it's working anaerobically, meaning without oxygen, and so the respiratory system isn't really being used as much, whereas with aerobic training it is. Even after lots of training, the cardiovascular system will have not much or no effect on the standing vertical jump. This is because it's such a short duration of only around 1 second or less, meaning the CV system wouldn't benefit a person doing the jump. The Wingate test, however, is affected by anaerobic training, as the individual will be able to work at a harder intensity or higher intensity during the sprint and get to a higher speed, as the right heart muscle is stronger and can pump more blood around the body per beat and so doesn't have to work as hard. But I'll be talking about the standing vertical jump and the Wingate test later on. The recovery time will improve with training, as more blood is being transported around the body, containing oxygen vital for the recovery process. If the heart can pump more blood per beat around the body, more oxygen is being transported, aiding in recovery. Also, because during exercise the heart rate is lower, this means that there's a quicker recovery from exercise, as it takes less time for the body to return the heart rate back to normal levels. Plyometric training can improve the recovery time, as the respiratory rate returns to normal faster and the waste products can be removed quicker. There are no waste products produced from the ATP to PC system, but from the lactic acid system lactate is produced. From training, the individual's lactate threshold becomes later, and oblet is delayed. If the lactate threshold is delayed, this means that the person can work for a longer amount of time before they experience the accumulation of lactate, resulting in a decrease in performance. Now, neuromuscular adaptations. Plyometric training, etc., doesn't have an impact on neuromuscular system. Fast glycolytic muscle fibers adapt as a result. They gain the ability to generate more power and force from strength. This is because they undergo hypertrophy, meaning they get stronger. This means that stronger contractions can occur, generating more power and force. Also, there is an increase in fast glycolytic and fast oxidative glycolytic fibers recruitment, meaning more are being called upon to create the desired force. The more fibers that are recruited, the more power that we generated. Hyperplasia is the increase in the number of muscle fibers. It is the action of splitting muscle cells which are contributing to muscle growth. There is some controversy, however, about whether adaptation to exercise leads to an increase in muscle fibers or if it's just an increase in muscle fiber size that ends up leading to muscle hypertrophy. It is said that males adapt better as a result of training, as they have more testosterone. So this increases their muscle mass at a faster rate than with females. In women, however, their muscles repair faster, but the males develop muscles quicker due to the testosterone. Fast oxidative glycolytic fibers increase from training. There's an increase in recruitment of these fibers, meaning that more power and force can be generated. The fast oxidative glycolytic fibers will experience hypertrophy, so they can generate more power and force as they become stronger. The adaptation of these fibers mean that sporting performance is improved, as an individual will be able to exercise at a high intensity, as these fibers will be generating lots more power, meaning the person can complete their activity at a higher standard, and so their performance will be improved. These fibers become better after anaerobic training. As skeletal muscles increase in size, they become stronger and just generally more effective. Tendons help to avoid injury by keeping up with the demands from the increased forces of contraction. From plyometrics training, which involves a lot of bounding and leaping and jumping, the tendons need to become stronger to withstand all movements. The adaptations of the tendons occur before muscle growth, which is hypertrophy, as stronger tendons are needed to lift heavier weights. The body adapts by generating new tissue made of protein, which is mostly collagen. The increased collagen means that there's an increased thickness of cartilage at the end of the bones, making the joints stronger. This increased strength of the tendons helps the performer not only avoid injuries, but can also help them increase the bone mass and enable the individual to lift the heavier weights. Proprioceptors will be able to detect changes at a faster rate. The muscle spindle apparatus detects the stretch and sends an impulse. The impulse tells the muscle to contract with greater force. This is so that the speed at which the muscle is being stretched decreases. By stretching a muscle prior to contraction, this means the muscle can create more force for the contraction, meaning the contraction will be stronger, and therefore an individual's performance will be better, as their contraction will have more power and force. With training, the muscle spindle apparatus becomes more sensitive. Feedback can enhance sporting performance. Neuromuscular pathways will adapt, and the impulses will be sent at a faster rate. This means that an increase in firing from the SA node, the sinoandroidal node, and this would therefore mean that their response rate, also known as their reaction time, will be quicker, which is very useful for a netball player, but I'll talk a bit more about that later on in the video. Training can change force generation. As the stronger the muscles are, the more power and force they can generate. By doing anaerobic training, the muscles will experience hypertrophy and so will get larger and stronger. If the muscles are stronger, that means they're able to generate more force. This means they'll be able to perform at higher standards. For example, they'll be able to jump higher or run faster. Now I'm going to talk about the energy system. With training, there's an increase in anaerobic enzymes. Enzymes in the body are required to break down ATP during exercise, which is either aerobic or anaerobic. If there's an increase in anaerobic enzymes, this means that the ATP is being produced at a much faster rate. After training, there are more anaerobic enzymes breaking down ATP. This is beneficial to the performer, as it means an individual will be able to perform their activity at a much higher intensity. The ATP store doesn't actually change with training. The main change is the increase in muscle mass. The phosphocreatine store changes with training and can also change with supplementation. There is increased levels of ATP and PC in the muscle, but only the PC store adapts with training. The phosphocreatine store size increases, meaning the individual can work for longer durations and higher intensities using the PC system. The muscle cells adapt as they become more able to store phosphocreatine. An example of supplementation that can aid an athlete includes: supplements are said to help aid athletes by enhancing athletes' physical performance. They are said that they can help athletes with bursts of strength, increase muscle mass, and help muscles recover faster during exercise or after exercise. Creatine supplementation is also said to increase the total creatine concentration in the muscles, meaning the PC store increases from taking the supplement. This means that an individual will be able to train at a higher level, and so the individual's performance will improve. A sporting activity which would benefit from increased PC stores includes the wing gait. Having greater phosphocreatine stores mean that the individual doing the test will be able to cycle at a higher intensity, and they will also be able to sustain that high intensity for the whole duration. This is because a greater phosphocreatine store means that more phosphocreatine is available to break down ATP, and so therefore more ATP is being produced at a faster rate. So the individual will be able to generate more force and power, improving their performance in the wing gait test. During the test, lactate builds up. This build-up and accumulation of lactate gradually will result in a decrease in performance due to the enzymes being inhibited from the increased acidity of the lactic acid. With training, the body deals with lactic acid more effectively by improving the body's lactic acid tolerance. The body has a higher lactate tolerance of lactic acid. As an individual gets fitter, lactate is broken down by oxygen into carbon dioxide and water. This is beneficial as lactate then doesn't enter the blood. Training anaerobically increases the buffering capacity of the body, meaning that an individual can work for longer durations at higher work intensities. Also, the body can work for longer and cope with the increased acidity, so therefore obla will increase. A trained athlete will reach obla at a later stage than an untrained athlete. This is beneficial for the trained athlete, as they will be able to work for longer amounts of time before the onset of blood loss occurs, and the individual's performance starts to decrease. In addition to that, training can also result in an increased ability to breathe out more carbon dioxide from the body, therefore delaying obla. This means that an individual's anaerobic performance will improve, allowing them to work at higher intensities and for longer durations before they are forced to stop the activity due to the accumulation of lactic acid. BMR stands for basal metabolic rate. It is about the amount of calories that a person can burn by doing nothing but resting for 24 hours. The BMR is increased by exercise and training. Exercise increases the amount of muscle someone has, and the more muscle an individual has, the faster the BMR. It's a representation of roughly the smallest number of energy that would be required to keep the body functioning. Some of these functions include breathing, blood circulation, controlling body temperature, and a couple of others. The BMR affects the rate at which an individual burns calories and therefore resulting in either weight gain or weight loss. And finally, the skeletal system adaptations. Training such as plyometrics can involve weight-bearing activities. Weight-bearing activities helps bone density by making stronger bones, so therefore increasing the bone density. Bone density is the amount of bone material in the bone tissue, the mass of the mineral per volume of blood. The bone density is used as an indicator of osteoporosis. Having stronger bones reduces the likelihood of osteoporosis. Osteoporosis is a condition which weakens bones, making them become weak and fragile, therefore more likely to break due to the loss of tissue. It results in bone loss. It makes people experience bone loss much faster than normal. The best way to reduce it includes eating foods rich in calcium, exercising, and making sure enough vitamin C is being got and is being absorbed. Osteoclasts and osteoblasts help to reduce the risk of getting osteoporosis. Osteoclasts are cells which destroy and break down bone and free calcium, which is then reabsorbed. It plays an important role in bone remodeling and healing, as it helps to regulate bone growth. Osteoblasts move to the bone's surface, making it denser, allowing the making of new cells at the periosteum. This is the outer layer of the cells. Osteoblasts deposit calcium into the bone, remaking it. The buildup of calcium makes the bone stronger. The range of movement with training increases. The individual will have better muscle balance, joint mobility, flexibility, and increased activation of working muscles, so overall just better quality movement. Flexibility can help avoid injury to both muscles and joints. Post-exercise, stretching can reduce the short-term muscle soreness and stiffness caused by exercise. With training, the cartilage gets thicker. Cartilage acts as a shock absorber. It's a cushion between the joints of bones. Some people can experience negative impacts on their cartilage with excessive training. If cartilage is lost and gets worn away, individuals will experience pain due to the actions of bone rubbing on bone. Ligaments connect bone to bone and so are very important in stabilizing joints. Ligaments are very strong and flexible. They become stronger and thicker with training. There's an increase in 20%, there's a 20% increase in strength and thickness of ligaments and tendons with regular training. Having stronger and thicker tendons improves an individual's performance, as they will be able to provide more support when performing and prevent any unwanted movement to keep the joint stable. The ligament's role is also to provide proprioception input to the brain that enables an individual to know what positions the joints are in. This is beneficial to the performer as they can perform more complex and coordinated movements in sport. To test if all of this training has worked on the aerobic and anaerobic exercise, there are different tests a performer could partake in. To test anaerobic improvements, the standing vertical jump and wing gait, and to test aerobic, the VO2 max. The standing vertical jump is a good test for anaerobic improvements. Pre-training, the netballer's height was 33.2 centimeters, and their time was 39.3 seconds. But post-training, the netballer's height was 39.3 centimeters, and their time in the air was 0.67 seconds. So post-training is the orange and pre-training is the blue. This is shown by the graph. It shows that after training, a netball player is able to jump much higher. This is because their muscles are stronger, so more force can be generated to power and lift them up in the air. So standing vertical jump is for very, very short duration of anaerobic exercise. Now I'm going to talk about the Wingate test. So the Wingate test is a good test for moderate anaerobic improvements. So the red line is showing pre-training and the blue line is showing post-training on the Wingate test. It shows that the training output, so with training and so post-training, the power output is much higher and they can sustain the power output for a longer period of time. Also, fatigue is resisted more post-training. Whereas with pre-training, the netballer's leg wouldn't have been as strong, and so there wouldn't have been as much muscle, so they couldn't generate as much power and force. But after training, the netballer's legs would have been stronger due to all the plyometric trainers, etc., meaning that they'd have greater forces in the Wingate test, and so therefore can have a greater power output in watts. This graph shows the VO2 max test data. The blue line is showing the VO2, an athlete's VO2 pre-training, so before they've undergone training, and then this red line is showing an athlete's VO2 post-training, so after they've completed their training. The graph shows that an athlete is able to keep their VO2 max lower before training. They are able to use smaller amounts of oxygen to work at the same speed. After training, the athlete is also able to continue for a much longer duration at a higher speed. The athlete's pre-training has to stop at around 13 kilometers per hour, whereas at post-training is able to continue for much longer and able to stop at around 17 kilometers per hour. This is beneficial to the aerobic system or the aerobic performer, as it shows that with training, an athlete is able to use oxygen more efficiently and is able to continue working for a longer duration and for a higher intensity. The pre-training individual's VO2 max is around 45, so there's their VO2 max, and then the post-training VO2 max is around 57. This graph shows that the trained athlete is able to keep their VO2 max at a lower level than the untrained athlete. The trained athlete is able to consume less oxygen but work for a greater amount of time at a higher intensity compared to the untrained athlete. From training, the centre player has improved in all of their fitness tests. I'm now going to talk about how this will improve their performance in netball as a whole. Being flexible means the player can reach for the ball for an interception and a 3-foot mark more effectively. Their reaction will be increased. This will help and improve their netball performance, as they will be able to react much quicker to any loose balls and can react quickly to perform an interception, meaning they're more likely to turn over the ball and win the ball, more likely to make a turnover and win the ball. Having stronger, more powerful muscles means that a netball player is able to jump much higher due to the extra power generated. If a netball player can jump higher, they're more likely to get an intercept. Also, stronger muscles mean that a centre player's passes will be stronger and faster, and so therefore will be harder for an opposition to intercept. Increased aerobic fitness means that a player can perform at a higher intensity for a longer period of time or duration. This means that they'll be able to run up and down the court more and help their team. They'll also be able to work for a longer amount of time before they fatigue. Having greater PC phosphocreatine stores means that the player will be able to complete dodges faster and drives towards the ball. This will mean that the centre player will be able to get away from their defender more effectively, meaning they're more likely to keep possession. All these systems will adapt to training, enabling a centre player in netball performance to improve as a result. Thank you.